Right now, using nothing but your own hand, try to tickle the bottom of your own foot. Go ahead. Try it on your ribs. Try it under your arm. Every spot on your body that turns into helpless, uncontrollable laughter the instant someone else touches it. Nothing happens. It never does. And you have known this without ever being taught it since you were a small child. Here's what should genuinely stop you in your tracks about that. This isn't a minor inconsistency. It's one of the strangest, most consistent facts about the human body, and it took neuroscientists using actual brain scanners to figure out why. Your body has, quite literally, built a machine whose entire job is to make sure you can never surprise yourself. Let's start with the obvious wrong explanation, the one that sounds reasonable until you actually think about it. Maybe you just know it's coming. Maybe the anticipation ruins the effect. Except that explanation collapses instantly under a simple test. Have a friend tickle you while you know exactly when and where it's about to happen, watching their hand approach in slow motion, fully braced for it. You still laugh. You still squirm. Full anticipation, zero immunity. Whatever is blocking self-tickling, it isn't about surprise. A neuroscientist named Sarah-Jayne Blakemore, working at University College London, set out to find the actual mechanism, and the answer she uncovered lives in one of the most underrated structures in your entire brain, the cerebellum, a dense, ancient region tucked at the base of your skull, largely responsible for coordinating movement and, critically, for something most people have never heard of: prediction. Here's the part that changes everything. Every single time you move your own body, your brain doesn't just send the command and wait to see what happens. It simultaneously generates an internal forecast, a prediction of exactly what sensation that movement is about to produce, generated milliseconds before the movement even completes. Reach your own hand toward your ribs, and your cerebellum has already calculated, in advance, precisely how that touch is going to feel, where, and how intensely. Blakemore used brain imaging to directly compare what happens when a touch is self-generated versus when the identical physical touch is delivered by someone or something else. The results were remarkably clean. When a touch was self-produced, activity in the somatosensory cortex, the brain region responsible for actually registering the sensation of touch, was measurably dampened compared to the exact same touch delivered externally. Your brain, having already predicted the sensation with near-perfect accuracy, essentially turns down the volume on it before it even arrives. The prediction cancels out a significant portion of the surprise, and surprise, it turns out, is the actual active ingredient in a tickle. This single mechanism, called sensory attenuation, is doing enormous, mostly invisible work throughout your entire life. And tickling is really just the strangest, most noticeable symptom of it. It's the same reason you can't make yourself flinch by moving your own hand quickly toward your own face, even though an identical fast motion from someone else triggers an instant flinch. It's the same reason your own voice sounds quieter and less startling to your own brain than an identical volume of someone else's voice would. Your brain is constantly silently forecasting the sensory consequences of your own actions and preemptively discounting them, precisely because a system that gasped in surprise every time you moved your own arm would be a catastrophically inefficient way to run a nervous system. Think about what the alternative would actually look like if your brain treated self-generated touch exactly the same as external touch. Every step you took would register as a small, unexpected jolt against the sole of your foot. Every time you scratched an itch, your own fingernail would produce a genuine startle response. You would be perpetually ambushed by your own body, incapable of distinguishing your own actions from an outside threat, burning enormous cognitive resources reacting to sensations you caused yourself a fraction of a second earlier. The cerebellum's prediction system exists to prevent exactly that, and the inability to tickle yourself is simply the one place where the mechanism's blind spot becomes obvious enough for you to actually notice it happening. Now here's where the research gets genuinely strange, because it turns out this system can be broken on purpose in a laboratory, and watching it break tells you almost everything about why tickling from another person works in the first place. Blakemore's team built a mechanical device that let a person tickle themselves indirectly, using a robotic arm they controlled with their own hand, but with a small, adjustable time delay inserted between their movement and the resulting touch. When the delay was extremely short, near instantaneous, participants reported almost no ticklish sensation, exactly as you'd expect from ordinary self-tickling. But as researchers increased the delay, even by a fraction of a second, the self-produced touch started registering as noticeably more ticklish. Push the delay far enough, and self-generated tickling using the robotic device began approaching the intensity of being tickled by another actual person. That result is the whole mystery laid bare. The cerebellum's predictive cancellation system depends on tight, precise timing between your movement and the resulting sensation. Introduce even a small gap, and the prediction and the actual sensory outcomes stop lining up closely enough for the cancellation to work properly. The brain, no longer able to confidently match cause and effect in real time, starts treating the touch as if it came from an unpredictable external source, and the ticklish sensation comes roaring back. Which means an external tickler isn't producing a stronger sensation than you could theoretically produce yourself. They're producing an unpredictable one, and unpredictability, not pressure or location, is the actual mechanism doing all the work. Another person's hand can't be perfectly forecast by your cerebellum because your cerebellum only builds precise predictions for movements your own motor system initiated and controls. Someone else's exact timing, pressure, and trajectory sit permanently outside that predictive model, no matter how many times they've tickled you before or how well you know it's coming. Which is exactly why anticipating a tickle from someone else never dulls it the way self-generated touch automatically does. There's a reason to believe this system runs deeper than simple sensory housekeeping, too. Some researchers studying the social function of tickling have proposed that ticklishness, concentrated so heavily around vulnerable areas like the ribs, neck, and underarms, may have originally evolved partly as a kind of play-based vulnerability test between closely bonded individuals, parents, and infants, or close social partners, a way of practicing defensive reflexes and reinforcing trust in situations where physical vulnerability is being deliberately, safely simulated. Under that framing, the fact that you can't trigger the response yourself isn't an unfortunate side effect. It might be closer to the entire point, a signal that only functions biologically when it comes from someone else. Put together, the picture that emerges is almost the opposite of how ticklishness feels from the inside. It doesn't feel like a sophisticated predictive computation running constantly in the background of your nervous system. It feels like a simple, almost silly quirk of the body. But underneath that quirk sits one of the more elegant systems your brain runs at every waking moment, silently forecasting the sensory consequences of your own existence, so precisely and so continuously that the one time it visibly fails to cancel a sensation, another person's unpredictable hand against your ribs is often enough to make you completely lose control of your own body in helpless laughter. So the next time you try, and fail, to tickle your own ribs, know exactly what's actually happening. You're not missing some ticklish gene, and there's nothing wrong with your nerve endings. You're simply too good, in that single specific moment, at predicting yourself,